Welcome back to the deep dive. If you follow climate discussions, it's just a massive amount of information out there. Can feel overwhelming sometimes. So today, we're aiming to cut through some of that noise. We've got the stack of research, articles, notes you've shared, and we're going to distill the key stuff, our mission. Get you even more thoroughly informed, quickly and clearly about, climate change. A topic that really does touch all of us.
It absolutely does. And understanding it isn't just about memorizing facts. It's more about getting a feel for that complex interaction, between Earth's natural cycles, which go back forever, and our increasing human footprint.
Right.
It's this force that's, reshaping our environment, challenging economies, hitting our health. It really sets the stage for where we're headed collectively. So in this deep dive, we'll look at the evidence, the hard data. We'll try to unpack the causes, both natural and human, highlight the effects, which are pretty wide-ranging, and crucially, look at how we're trying to manage it all.
Absolutely. So get ready for maybe some surprising connections. We'll try and break down what can feel like just too much information sometimes. Let's jump right in. So we know Earth's climate isn't fixed. It's always shifted, right? Colder periods, warmer periods. I mean, just look at the Quaternary period. That's the last, 2.6 million years. It saw something like 60 different cold spells and warmer times in between. But the pace of change now, that seems to be the real story, isn't it?
That's a really crucial distinction, yeah. We understand those ancient shifts through some incredible evidence, like ice cores. Scientists drill deep into ice sheets, and these cores trap tiny air bubbles, ash, even microbes from hundreds of thousands of years ago. It's like a frozen timeline.
Wow.
Then you've got preserved pollen, which tells us about past vegetation, so we know what the climate was like. Tree rings, too, they give us annual records of growth, showing good years, bad years, temperature, rainfall.
Amazing detail.
And even things like old diaries, paintings showing frozen rivers, early weather records. They all add pieces to the puzzle, especially for the more recent past. Having this deep historical baseline is what really helps us see how different today's changes are. Puts it in perspective.
It's wild to think centuries-old diaries are giving us climate clues. Okay, so with that long view, what are the big signals now? The things telling us something different and, like you said, much faster is happening.
Well, the current data paints a pretty stark picture of acceleration. You look at Arctic sea ice, it's hitting record lows. Glaciers, pretty much everywhere, are visibly shrinking. And sea levels, they've risen about 23 centimeters since 1880. That's not just meltwater adding volume. It's also that warmer water literally expands, takes up more space.
Right, thermal expansion.
Exactly. And biologically, we're seeing shifts too. Plants flowering at different times, bird migrations changing, nesting happening earlier, animals cutting hibernation short. It's like the whole system is responding.
Yeah, sounds like the planet's internal clock is speeding up somehow.
That's a good way to put it. And maybe the most compelling piece of data tying it together. Think about this. The 15 hottest years ever recorded globally all happened between 1995 and 2017.
15 years, all packed in that short window.
All packed into roughly 2 decades. That concentration of extreme heat is, it's statistically remarkable and really underscores why there's so much urgent discussion now.
Okay, so the planet is changing, and fast. We've got that. But let's talk about why. The natural greenhouse effect that's necessary for life, right? Lets sunlight in, trap some heat.
Absolutely essential. Without that natural blanket of greenhouse gases, Earth's average temperature would be a freezing minus 18 degrees Celsius. Uninhabitable for us.
Right. So life depends on it.
Totally. And these gases have natural sources. Water vapor, obviously, from oceans, lakes, plants. Carbon dioxide from volcanoes, wildfires. Even us breathing. Methane comes from swamps, decaying stuff. Termites.
Termites again.
And nitrous oxide from soils and oceans. These are all part of the natural system.
And besides those gases, there are other big natural drivers, right? Those long-term cycles.
Yeah, exactly. Things like the Milankovitch cycles. These are very slow, predictable changes in Earth's orbit around the sun, its tilt, its wobble. They affect how much solar energy reaches different parts of the planet over tens or hundreds of thousands of years. Huge time scales.
Okay.
Then you have massive volcanic eruptions. They can throw so much ash high into the atmosphere that it actually blocks sunlight and causes temporary cooling.
Right, like a sun shield.
Sort of, yeah. And sunspot activity periods with more sunspots seem to correlate with slightly warmer periods, though that's still debated a bit. Even atmospheric dust, maybe from asteroids, could play a role. But again, these are mostly slow, natural processes.
So if those natural things happen over millennia, what are we doing that's causing this enhanced effect, speeding everything up so much? This is where it gets interesting. We're worrying.
Well, this is the core of the issue. It's the sheer volume and the speed at which human activities are adding extra greenhouse gases. We're essentially thickening that natural blanket way too quickly.
Okay, break it down for us. What are the main human sources?
Okay, so for carbon dioxide, CO2, the big one is burning fossil fuels, coal, oil, gas. That's for power plants, cars, industry, heating. Then there's deforestation. Fewer trees mean less CO2 being absorbed.
Right.
For methane, CH4, think about organic matter decaying in landfills without oxygen. Also, livestock farming, especially cattle and rice cultivation in flooded paddies, release a lot of methane. Nitrous oxide, N2O, comes largely from agricultural fertilizers, soil management practices, and also burning fossil fuels. And then there were CFCs, chlorofluorocarbons, used in aerosols, refrigeration. They were phased out mostly because they damaged the ozone layer, but they were also potent greenhouse gases.
So it's a mix of things from different sectors.
It is, but some are bigger slices of the pie. Fossil fuels are huge, maybe close to half of all global greenhouse gas emissions, powering almost everything we do.
Wow, nearly half.
Yeah. Agriculture is another major one. Clearing forests for farms or grazing, making fertilizers, raising livestock like cattle, growing rice. It all adds up. Even making cement for construction releases CO2 when limestone is processed. And transport, just more people means more cars, trucks, planes using petrol and diesel.
It really touches almost every part of modern life, doesn't it? So, okay, connect the dots for us. What does this buildup mean? These aren't just numbers in the atmosphere. They have real-world consequences. Let's start with people, our health, our communities.
The impacts ripple outwards, definitely. Socially, health is a big one.
Yeah.
Higher temperatures can help diseases spread. Malaria, for example, showing up in Italy again since 2017. Some projections suggest hundreds of millions more people could be exposed globally.
That's huge.
Yeah. And heat waves themselves mean more heat stroke, dehydration, bad sunburn.
Right.
Plus, heat can worsen air pollution, which is tough on people with respiratory or heart problems. If climate change disrupts farming, food shortages could lead to malnutrition. Now, maybe milder winters mean fewer deaths from cold in some places, but the overall health picture looks challenging.
And these health issues, community disruptions, they must hit the economy too.
Absolutely. They're deeply linked. Think about jobs. Tourism ski resorts might struggle without reliable snow. Coastal resorts face flooding threats. That impacts local economies heavily. Agriculture can. Farmers might have to switch crops, maybe find new ways to irrigate if water becomes scarce, or even stop farming some areas. Fisheries can decline too. And settlements. Low-lying coastal areas are particularly vulnerable. They might need incredibly expensive sea defenses, or in some cases, people might have to relocate entirely. Think about island nations like the Maldives. Some scenarios suggest large parts could be uninhabitable by 2050 without drastic, costly action.
The scale of that is hard to grasp. And beyond the direct human and economic costs, what about the fundamental changes to the natural world itself, the ecosystems we rely on?
That's perhaps the most profound area. Let's revisit sea level rise. We mentioned the 23 centimeters since 1880 and the thermal expansion. Forecasts suggest another 30 centimeters just by 2050.
Another 30 centimeters.
That's a common projection. Think what that means. More beach erosion, damage to vital coastal habitats like coral reefs and mangrove swamps, which are natural buffers themselves, and salt water getting into freshwater sources, ruining drinking water and irrigation.
And extreme weather. We hear about that constantly.
Yeah, the evidence points to increased frequency and intensity of natural hazards. The Atlantic hurricane seasons in 2020 and 2021 were incredibly active, breaking records. Longer, more severe droughts are happening in many regions, which then fuel devastating wildfires. We saw terrible examples in Australia, Greece, the U.S., just in 2021.
It feels relentless.
It does. And then there's the deeper ecosystem shifts. Entire biomes, like climate zones, are shifting towards the poles. Polar and tundra environments are really shrinking. Their species are at high risk. In the oceans, warming water and increasing acidity from absorbed CO2 cause coral bleaching on a massive scale, which devastates marine life that depends on reefs. Animal behaviors are changing too. Fish moving to find cooler water, hibernation periods changing, migration patterns shifting. Even pests and diseases are on the move. Those malaria mosquitoes might start thriving at higher latitudes where they couldn't before.
Wow. It's not just isolated instances. It's like the whole web of life is being rewired, stressed. A cascade of changes.
That's a very good way to put it. It's interconnected. Social and economic impacts often stem directly from these fundamental environmental shifts.
Okay, so faced with, well, all of that, what can actually be done? You hear about mitigation and adaptation. Can you break those down?
Sure. They're the two main approaches. Mitigation is basically trying to reduce the severity of climate change itself, primarily by cutting greenhouse gas emissions, slowing it down at the source. Adaptation is about adjusting to the climate change that's already happening or is now unavoidable, learning to live with the impacts and reduce vulnerability.
Got it. So reduce the cause and cope with the effects. Let's start with mitigation. What does that look like?
A huge part of mitigation is international cooperation. You need global action. The IPCC, the Intergovernmental Panel on Climate Change, was set up back in 1988 to provide the scientific assessments. Then came major agreements. The Earth Summit in Rio, 1992. The Kyoto Protocol in 1997 was a big step. It set actual emission reduction targets for developed countries. But it had challenges, like the U.S. not ratifying and China, as a developing nation then, not having binding targets. It taught us a lot.
Lessons learned for the next attempt.
Hopefully. The Paris Agreement in 2015 was a breakthrough in many ways. It set a global goal: keep warming well below 2 degrees Celsius, preferably aiming for 1.5 degrees compared to pre-industrial levels. And crucially, almost every country signed on, including the U.S. and China, pledging their own national contributions. The U.S. did leave for a bit, but rejoined in 2021. And these annual COP meetings, Conference of the Parties, like COP26 in Glasgow, COP27 in Egypt, they're where countries try to hash out the details and increase ambition.
So policy is key. What about technology and practical actions?
Big time. Shifting energy sources is critical, moving away from fossil fuels towards alternatives like wind, solar, hydroelectric power, tidal, geothermal. These are renewable, and their emissions are far, far lower over their lifetime, even counting construction. Plus, they're getting cheaper.
Okay, energy transition. What else?
Afforestation, simply planting more trees. Trees are brilliant carbon sinks. They absorb CO2 through photosynthesis. They also produce oxygen and can even influence local weather, like increasing cloud cover slightly. And then there's carbon capture and storage, CCS. This is technology designed to capture CO2 emissions, say from a power plant, before they reach the atmosphere, compress the CO2, and then store it deep underground, perhaps in old oil fields. It's complex, expensive, and there are questions about long-term storage security, but it's being actively developed.
Right. So mitigation is about stopping the problem getting worse. But for the changes already locked in, we need adaptation. How do we adjust?
Yeah, adaptation is vital because some level of change is already unavoidable. Agriculture is a prime example. Farmers need to adapt to shifting weather, new pests, different diseases. That might mean switching to different crop varieties, maybe ones that are more drought-resistant, or changing livestock types, or using totally different techniques like those floating gardens in places like Bangladesh that can cope with floods.
Clever. What about water? That seems like a big one.
Huge. Managing water supplies is critical. On the demand side, things like more efficient appliances, fixing leaks. On the supply side, maybe investing in desalination plants to make seawater usable, though that's energy intensive, or building more reservoirs, and definitely improving irrigation efficiency so less water is wasted.
And for those rising sea levels we talked about.
Reducing that risk involves a range of strategies. You can build hard defenses like seawalls, the Maldives is investing heavily in these, or work with nature, like restoring mangrove forests, which are fantastic natural barriers. In some places, it might mean raising buildings up on stilts, or even constructing artificial islands at higher elevations. And then there are large-scale engineered solutions like the Thames Barrier in London, designed to protect against storm surges.
It seems like there are lots of options, but they must vary hugely depending on the place and the resources available.
Enormously. Adaptation is often very local and context-specific. What works in the Netherlands might not work in Vietnam or Florida. And crucially, cost is a major factor. Wealthier nations generally have more capacity to adapt.
Which brings up an important point. Can we really choose between mitigation and adaptation? Or do we have to do both?
We absolutely have to do both. They're two sides of the same coin. The more we mitigate, the more we reduce emissions now, the less severe the impacts will be later, and the less adaptation will be needed, or at least the adaptation required will be less extreme and costly. But because of the emissions already in the atmosphere, some climate change is already baked in, so we must adapt to cope with those unavoidable changes. It's not an either, it's a both hand, and they need to happen together.
What a deep dive that was. We've gone from, ancient ice and million-year cycles right through to the latest international climate talks and local adaptation projects. It really highlights how complex this is: natural cycles, human impacts, the knock-on effects on society, economy, environment, and then all the ways we're trying to respond.
It truly is multifaceted, and I think grasping that complexity, seeing the links between ancient pollen, modern power plants, and future seawalls, is what empowers us. It lets us think critically about the information we hear, about our own role, and about the kind of future we're steering towards.
So, listening to all this, what does it mean for you? Here's something to maybe chew on. Think about that connection between the global and the local. How do those big decisions made at international summits trickle down? How do they relate to choices in your own community, maybe even your own home or daily habits? And how can all those small adaptations added together actually contribute to managing this huge planet-wide challenge? Lots to think about. Thank you so much for joining us on this deep dive. Keep digging, stay curious.